So yeah. All right. So let's talk about this. I need eyes and attention up on the board. I need us actively engaging our brains to think, Gerald, while I'm talking up here. All right. It's not to call you out to embarrass you. It's call you out because I need you to focus. If you want to learn well, when I'm talking, I need you up here. All right. So, a couple of quick details I want to talk about before I even talk about this. First off, I've already had, I think, 4 or 5 people come in to start working on test corrections, and they don't have to say who they are, but for those who have come in, I feel like they've learned from their mistakes, and they understand the math better. When you analyze those mistakes, you'll grow and you'll improve, and we'll do better on a retest. Does anyone who came in want to say anything about agreeing or disagreeing with that statement? No? Too scared? Alright, anyways, come in, ask questions, and learn from your mistakes. I will say, I'm glad that Omar talked to me at one point yesterday because I realized that there was a misconception, and this is probably not just for him, for multiple people, about what we're doing with transformations, which is why the first question is on the bell ringer. If you talk, I can hear your misconceptions, and I can do things to address those misconceptions to help you learn better. This is why I need you to talk. It's one of the reasons I need you to talk and discuss and try to hash these things out. Alright, so let's look at this first question. So I'm going to come back to this slide in a second. So let me collect. No, that's not what I want. I want that one and that, and let's delete. So first things first. The very first question was it Frank? Is that the name I used? Yeah? Thanks for whoever confirmed. I appreciate you. Alright. So, Frank was trying to explain to Wendy how to solve this equation since our transformations. Analyze this previous statement. So, alright, so I see someone here saying that they should have said translations instead of transformations. But if I want to point this out, whoops, f of x equals -3 times x minus 2 squared. Are there only translations here? No. When we say transformations, that's the umbrella term for translations, dilations, and reflections. All 3 of those are types of transformations. So there's a reason why they should have said transformations. I want you to notice right here, and I think this person meant to say can't. What does the word solve mean? Find out what makes the equation or the inequality true. So can you solve in this situation? No. I need you to hear me very clearly on this, because this is one of the reasons why I'm so particular on vocabulary in mathematics. If you think I'm trying to solve this, you're completely off base and you're going to be super confused. I'm not trying to solve anything. I'm not trying to find what makes that equation true, not in the sense that you're thinking. What I'm trying to do is figure out how to go from a parent function, which remember we want to be more accurate than this. I want to figure out how to go from this parent function, because what is this parent function? F of x equals x squared. Thank you, right? We know it's a parabola, so we know it's quadratic, right? I want to know how to go from this parent function to this transformed function. I'm not solving anything. I'm just trying to figure out how to go from this parent function to this transformed function. What are the points that would work for this one? Well, not -3, 2. We'll go into more detail about that in a second. But I need you to notice and understand. Am I solving anything here? Not at all. Not solving. And if you think solving, you're going to be in a world of hurt. Not solving. I am transforming this parent function into this function. And I can do that in which representations?
Graph.
Say it again.
Graph.
Can I take a parent function in a graph and transform it into this function on the graph?
Yep.
Yeah? And what else? A table. Tables and graphs, and we can even take tables and graphs and go to the equation. But I need you to understand what we're trying to do is translate among those representations. All right, the next couple of questions deal very heavily with this equation up here. The first one, what mathematical operation creates a translation? All right, so I would guess this is supposed to be saying a minus and a plus, so addition and subtraction, right? Addition, the plus C and the plus D. I need you to make sure that you write this fundamental idea down under translations. The operation of what? What operation is creating a translation? Remember the bell ringer was just the operation, so the x squared is the parent function, right? The operation of addition, and I'm going to put in parentheses and subtraction, creates translations. This is foundational to everything we're going to study and learn. And I need you to understand, an operation is not a transformation, or addition and subtraction is not a translation, but that addition and subtraction creates a what? Translation. There's a very important difference in that language. Because for you to say one thing is another, you're saying they're exactly the same, and they're not. Are they related? It's okay, Destin, you can nod yes. You started there, right? Yes, they're related, but one is not the same as the other. One creates the other, right? So anytime I see a translation, it was created by addition or subtraction. That's fundamental. Anybody have an idea why I put and subtraction inside of parentheses there?
Got the inverse?
So it's the inverse, subtraction is the inverse of addition. Remember, anytime I have 5 minus 3, can I rewrite that as 5 plus negative 3? Right? Subtraction is just adding a negative, right? So when I say subtraction, really, that's a form of addition. We good with that idea? Good, Jenny? Ishmael? Alright, Alan, you good with that idea? Yes, Mr. King. Thanks, guys. I appreciate it. Oh, yeah, let's move on. Okay. So the next question, actually, before I continue, what are your questions about the translations and the relationships with addition and subtraction?
None.
Got one person's good. Everybody else good? Okay. So don't forget, anytime I see addition or subtraction, I automatically recognize it as a translation. Alright, the next one. What mathematical operation creates a reflection? So there's a little bit more variety in here, but what's the most common answer?
Multiplication.
Multiplication.
Yeah.
Does any multiplication, though, create a reflection? Like, if this was 3 times x squared, is that going to be a reflection? So does anyone see an answer up here that is probably the most accurate?
Multiply by a negative.
Oh.
Right? Remember how when we multiply by a number less than 0, it's what reflects it? Because let's say I have the number 7. If I multiply that by 2, that just gets bigger. That would be a stretch. But if I take 7 and I multiply it by a negative 2, does it still stretch? Yeah, it got bigger, but also it became negative, so that's a reflection. Okay? So, when I look here under reflection, what should I write? What operation is creating that reflection? Multiplying by a negative. So, multiplication by a negative creates a reflection. Doesn't matter if it's a negative 0.1, a negative 5, a negative 1,000. Multiplication by any negative creates a reflection. That is an important detail to hold on to. So I've got to ask an important question here. Okay. Anna, is multiplication the same thing as a reflection? Or multiplication by a negative, is that the same thing as a reflection?
No, yeah. Maybe.
Maybe? Okay.
Maybe.
Maybe. Does anyone want to push back on that or ask a question about that?
Somebody else put.
What was the question?
The question was, is multiplication by a negative the same thing as a reflection?
Yeah.
No.
I hear some debate there. Who says, quick thumbs up if you say yes. And thumbs down if you say no. The question is multiplication by a negative the same thing as a reflection? So thumbs up if you say yes it is, thumbs down if you say no it is not. Okay? So I got mostly no's. Okay, so Omar, tell me why you're thinking yes.
If it creates a reflection, I thought it would be a reflection.
Okay. Does anyone want to push back on that statement or ask a question about that?
That's what I was thinking, you just said it creates a reflection.
Okay.
So I don't see how it couldn't be one.
So I saw a lot of no's. Who wants to share why no? Kyle, you said no, didn't you?
No, I didn't. I didn't even put my hand up.
Oh, then you get to volunteer now to say something.
What?
What's your reasoning? What do you think?
Honestly,
Is multiplication by negatives, is it a reflection?
Mm-hmm.
Okay, let me
Is it a reflection, so yeah?
let me point this out. This right here is multiplication by a negative, right? Multiply by a negative. After I multiply by a negative, do I get a reflection? It is the opposite, right? Okay? But notice it is creating a reflection. Just because it creates, does that mean it is that same thing?
No.
No. Remember, and this is the distinct difference. Where do we see the transformation of a reflection? On what mathematical representation? A graph, or maybe even a table, but really just a graph. The transformations are on the graphs. But where do I see the multiplication by a negative in the equation? Are they very related? Yes. But one is showing up algebraically, one is showing up, where's the reflection showing up? Graphically. You see that distinct difference?
I don't know how to say that.
Huh? Graphically?
I can't say it.
Say it. Graph. Graph.
Graph. Yeah.
Totally.
Really.
Graphically. That's it.
I be saying it, my tongue be.
You're good. You gotta practice it. Alright, anyways. We gotta recognize that difference. Are they related? 100,000% yes. Are they exactly the same?
No.
No.
So my first answer was right.
Wow.
Your first answer, I think you did say yes. Okay.
I said no.
Oh, did you say no? Okay.
I said no too.
Sure. Dilation. What creates a dilation? We're all over the place again. Okay, so compressions and stretches are dilations, but what's creating the dilations? It can be division, but really, like, do you see division up here? No.
Should it be subtraction?
I thought addition and subtraction were the translations.
Multiplication.
Multiplication. Yep. And so, because remember, the reflection was not just multiplication, specifically is multiplication by a negative. That's what makes it a reflection. What makes it a dilation? Well, it's a stretch when multiplying, there you go, by a factor greater than 1. I know, we all do. Technically, I'm going to say the absolute value of the factor is greater than 1. The reason for that is, when we multiplied by -2 over here, yes, it reflected, but did it also stretch? Well, it stretched because 2 is greater than 1, right? So as long as the absolute value is greater than 1, it's going to stretch. So even if you multiply by a negative, yes, it reflects, but it also stretches.
What did it say? By what?
Oh.
Absolute value of f.
Oh. I thought it was
Those are absolute values, so absolute value of f. Glad you asked that question. Well, I I need y'all to remember that it can show up, but at the same time, this is why when it came to solving equations, I was so emphatic about the multiplicative inverse. 2. What is the multiplicative inverse of 2?
Negative.
That's the opposite, the additive inverse. How about
1
1
time.
over 2.
1 what?
Divide
by
by
2. So remember, the idea of dividing by 2 is equivalent to multiplying by 1/2. So instead of showing it as division by 2, we're usually going to show it as multiplication by the reciprocal. Does that make sense? And so when I say multiplying right here, that would include the division. But remember how earlier with translations I said addition and in parentheses I said and subtraction? Because anytime I subtract, I can rewrite it as addition. Anytime I divide, I can rewrite it as multiplication. Right? Dividing by 2/3, does anyone know what that would be equivalent to when multiplying?
3 divided by 2.
3 divided by 2, the reciprocal. So anytime you're talking about division, I'm going to rewrite it as multiplication. Okay? What are your questions from there?
None.
Thank you, Jakila, for answering. Gerald, what are your questions from there?
What I need to write for payment folks.
We did that a while ago. We're not doing that right now. You can get that note from somebody else. Have you gotten this information?
Yeah, I got it.
Do you understand it?
Yeah.
Okay. Kylie, what were you going to ask? Daniel, Anthony?
Didn't you say there was a time like when you're doing reciprocal multiply across?
Well, anytime, so like if I have 7/2 times 1/3, anytime you're multiplying a fraction, you multiply the numerators and you multiply the denominators. Which is why if I have 2/3 and I multiply by 3/2, right? You multiply numerators, that's 6. 3 times 2 is 6, which is 1. Remember, when we use the multiplicative inverse, we're creating the multiplicative identity of 1. Does that answer your question? Okay.
Because on the test I did like the.
Yep. Well, and you can, so you notice when multiplying, it creates this, but what is 2 divided by 2? Right? So if it's in the numerator and then in the denominator, that's literally 2 divided by that 2 creates that 1. And then 3 divided by 3 creates that 1. So 1 times 1 is still 1. It's just alternate ways to show that. Yeah. Okay. So when's it a compression? So we got to get moving. When what?
Multiply. What's the freaking
By, less than 0. Between 0.
Is it less than 0?
Between 0 and 1.
It has to be between 0 and 1. 0 is less than, I'm going to say the absolute value of f again is less than 1. And that's because if I have negative 0.5 times x, that negative is going to what? What's the negative do?
Making a reflection.
That creates the reflection. The fact that it's 0.5 would make it a dilation.
So if it got a point, it's a dilation. That's good.
Well, as long as this isn't a 1, it's a dilation. Because remember, if it's greater than 1, it's a stretch. And if it's between 0 and 1, the factor is it's a compression. So you have to separate the negative from the other thing. If it's a 1 here, it doesn't stretch or compress. It's definitely went longer than I thought it would. It happens. Yes, ma'am.
Can I go fun now?
Yes, I'm so sorry. Be quick. Alright, last question to look at, we'll be quick on this. This is an important one. How are the transformations created by A and D similar? Now, I see A and D both get subtracted. A is multiplying and D is adding, but I want to point this out. If you're saying A is multiplying and D is adding, is that an incorrect statement? No, that's true. But that's not how they're similar. That means A is creating a dilation, maybe a reflection, and D is creating what transformation? Translation, right? What about B and C are on the inside and A and D are on the outside? The fact that B and C are on the inside of the main operation means it's doing what?
What's that?
Remember, that's multiplication, that's addition. If the operations are on the inside of the main operation,
Inverse.
Horizontal translation.
Horizontal.
does it have to be a horizontal translation?
Transformation.
It just has to be a horizontal transformation, because again, that's multiplying. So that's going to what?
Move horizontally.
If it's multiplying, what did y'all just write down for multiplying? Under what transformation? It could be a reflection
Dilation.
or a dilation. This addition would create a translation. And I need you to hear me very clearly on this. When it comes to transformations, you have to think about two things. One, what transformation is it? The transformation is defined by the operation. Right? Addition is going to create a translation. Thank you. Whew. Multiplication can create a dilation or a reflection. So you got to recognize that first and foremost. The second part is, hey, that's inside, so it's going to transform it horizontally. Notice how it's with the x? Which direction is your x variable? Horizontal, right? Yes, Mr. Kenny?
Yeah.
Thanks,
Yeah.
guys. So are you good with that? Okay, cool. So, horizontally. That's inside the main operation. Notice then A and D are where?
Outside.
Outside. So what direction is that going to transform the function? Vertically. So we've got to recognize that we have to look at what transformation is it, and we have to look at what direction is it. Okay? The last thing to keep in mind is all the horizontal transformations act the...
Same.
Nope.
Symbol.
Nope.
Wait.
What did you ask?
Remember, horizontal, if I have f of x equals x minus 5 squared. First off, what type of transformation? Type of transformation.
Translation.
That's a translation. We're subtracting. What direction is that translation going to go?
Right.
But it's minus.
It flips.
You gotta flip the sign.
Okay, you got to flip the sign. Let's be more
Inverse.
mathematical.
It's
Oh, it's the inverse. Every horizontal transformation acts the
Inverse.
inverse.
Okay.
So when we have subtraction, it actually ends up the idea of adding, and it goes to the right. If I have this, that looks like it would be a stretch, but what's the multiplicative inverse?
Division. Oh,
Reciprocal. See how that is times 2, so now I'm doing 1 divided by 2. If you multiply by 1/2, is that going to stretch or compress? That's going to compress it, right? Notice how I kept using f for the factor. The factor is a 1/2. That's going to compress it in which direction?
Horizontal.
Right, horizontal. You got to separate horizontal versus vertical. Jenny, why do I know that this is going to be horizontal? And not, so we need to be careful, you're close. It's not just about the parentheses, it's inside of the what? The main operation, which is the, not the x.
Huh? Wait, what?
What is the main operation? Someone said it earlier.
2x.
What defines the type of function? Type of function.
Transformation.
Type of function.
Square.
Squared.
Oh, the square.
To make it quadratic.
That's what makes it quadratic, right? So Jenny, just be careful, because if I were to give you this, there's no parentheses in that case. Does that make sense? But in this case, my main operation is the square root, so it's inside of that square root, so it's horizontal. So we can't just say, hey, it's parentheses. It's got to be inside of the main operation. What are your, yeah?
Anytime it's 2x squared, like how the second one is, it's always going to be the second one should be.
Well, and so you're trying to memorize just one specific case. Don't forget, when the transformation is in the horizontal direction, that transformation is always the inverse.
When it's horizontal.
When it's horizontal, right? And y'all have seen that with the vertex form all the way up through here. This says minus 5, but is actually going to go to the
Right.
right 5. Well, isn't the idea of adding 5 or going to the right the inverse of that idea? That's the additive inverse. I need the multiplicative inverse. And y'all kept balking at it every time I asked you to understand the multiplicative inverse, but this is why. It will help you. You've got to think through the multiplicative inverse to understand these transformations. It all builds. All right. I took way too much time on that. Ms. Courtney, do you want to get the practice part started? So, we will help support you, but you need to have these notes down, be prepared to discuss and practice these ideas. I'll pass the task out if you want to start talking them through the first little bit here. Oh, you need to go, we need the Desmos lesson, don't we? To finish those notes up? So, get out your Desmos activity lessons. Sorry, I forgot about that. Did you want me to pull up Desmos as well so that I can do the slider?
I only got 3.
Don't lie to me. My bad. I got you. Oh, you just want this up?
Did we talk about this question here? With the
I
dilation and a reflection?
think so, but we might want to still readdress it. At least, and if they already have it, then just quickly tap of it. You what?
We ain't talking about that.
We
We
did
did
not.
talk about
We
this?
did.
We did? No, okay. So this question is, see, it's under the lesson 2 notes. On page,
Slide 7, slide 8.
okay, under slide 7, slide 8. Oh, no, it's actually the one that's under slide 9 and slide 10. Because this is the one that has the negative in the transformation. So,
You said lesson
say that again?
2? You said lesson 2?
Yes, lesson 2 should be on the bottom. We're looking at the bottom of page 6 with those notes. Okay, guys. So these first 2 tables, if you're looking at like the stuff that's under slide 10, these tables up here represent so this would be the table for f of x is the square root of x, and then this was the table for the transform function of, see, g of x equals, okay. So do you guys have these tables filled in already for underneath slide 10?
I only got those.
Okay, so we're gonna go through this. So, okay. Mr. King, can you pull up the Desmos so we can look at it like in a minute?
Yeah.
Okay. So, are we all familiar with this parent function table for the square root parent function? Okay, so let's talk about how we can make this table. So remember with the square root, function, when we're reading this graph from left to right, we don't want to start with those negative x values, y. Right, like I don't want to have an x value of a -2 as an input. Why not?
You can't square a negative.
Right, because if I put that value in my calculator, it gives some kind of error output. So what do I need to start with for my square root? Okay, so if we start with the input of 0, we'll get an output of
0.
0.
I'm doing the next.
the next one. Okay, so the next point, if we put an input of 1, okay, so what should I put for my next input, Anthony? Okay, so if I input a 4 here, what would my output be? Okay, Kyla said 2. So where does that 2 come from, Omar?
Square,
Say that again.
square.
So, not quite the square, because what parent function are we dealing with here? The square root. Okay, so if I substitute a 4 into this, it'll take the square root of 4, that's what gives me a 2.
Why you choosing 4?
So, okay, so I chose 4, which when he pulls up the Desmos, I'll also be able to show you this. But, because remember, I could choose 2 and take the square root of 2 and have a decimal, but just for like my parent function table, I'm using numbers that will give me an output of a whole number. So, since my function is the square root, I'm choosing numbers that are perfect squares, right? Does that make sense? So you kind of choose different numbers based on the function you're working with. Okay, so knowing that, what would my next input value be?
8.
Would it be 8? Anthony? 9, right, because if I put in a 9, what's this output going to be? 3. Okay, so now this is all under slide 10. The transform, creating the table for the transform function now, let's just do it from the equation of it, okay? So, if this is the equation that I have, what operation's going on inside of a main, inside of the defining operation?
Dilation.
Right, a dilation, and you know that because of what?
Okay.
Right, so this multiplication, so what values are going to change of the on the table? Okay, what do y'all think about that? So why do you think I don't know who said that, why do you think the x values are going to change?
Because we multiply by 8.
Because I'm multiplying by x, does anybody else have any ideas for what's going to change? Are my y values going to change?
Yeah.
That wouldn't make sense. Y'all just said X.
Okay,
I
so
can't change either.
so why are my x values going to change, guys?
Because they being multiplied
But where is this multiplication happening?
in the square root.
From that one to the other side.
So,
Yeah.
but what? Okay, and the square root represents what?
The function.
Right. So we need to understand that because this multiplication is happening on the inside, my x values are going to change and my y values are going to stay the same. So, since the x values are changing, what kind of transformation are we going to have?
Horizontal.
Right. So, and when we have horizontal transformations, what do we have to be careful about here? So did we talk about in here yesterday when dealing with horizontal translation, or I'm sorry, I know we talked about horizontal translation, horizontal dilations, about what you have to do with that multiplication factor? Do you guys remember that?
Multiplicative inverse.
Right, we have to take that multiplicative inverse when I'm performing this transformation of values. So what does that mean I'm going to multiply my x values by?
1/3.
Okay, does anybody have any questions about that?
Wait, why was that?
Okay, So, we've established that we're taking a horizontal transformation, right? So, I have to take the inverse, the multiplicative inverse of this 3,
Oh, okay. I get it.
right? Because remember, horizontal, inverse. Gotta make your brain think like that. So, now I'm gonna be multiplying these x values by 1/3 to get my new ones, okay? So, let's do that to get these new values of the transform function. Okay, so first, let's see, so 0 times 1/3 is, 0 times 1/3 is,
Zero.
okay, and then you would take the square root of that. Okay, so then, do y'all see what I'll write it out. So then we do, or can someone tell me like the process to find the next one?
1 times 1 over 3.
Okay, so my next, I would do 1 times 1/3, and then remember, I'm still taking the square root of that because that's my function's main operation. Okay, so what's the square root of 1/3?
Zero point. It would be-
One,
What did you just ask?
Yes.
Yeah, he used 0.5.
So what's like 2 decimal, or 2 or 3 decimals? Point
77.
577?
Uh-huh.
Okay, so then how do I find what my next value is?
Do the same thing.
Okay, so what am I multiplying now?
4 times here.
Okay, so,
And then the square root.
okay, so when you perform that multiplication, and then take the square root, what do we get?
1.15.
Okay. Okay, what, do you have a question?
Yeah.
What's up?
where's the 4 come
Okay, so the 4 is I'm inputting these x values
from? Okay.
from over here to find the corresponding coordinates of like the new values. Okay, so when I find this value, or when I'm looking for this one, what am I gonna input?
No.
Yes. Okay, does that make sense? Okay, so I want you guys to try that one
Oh.
to get the what you're fine. Everyone try to do the one for 9, and then what do you get? Okay, thanks. Okay, so, Dawson, what did you get when you did that last one?
1.73.
1.73. Was that what you got, Collins?
Mm-hmm.
Okay. What?
Those are the x values that go to those y values?
Yes. I did not.
I would have thought it's for this one,
So,
right?
sorry, that was,
For
yes.
this one? I thought it'd be 1/3, 4/3, and 3.
Well, do you not take the square root of it?
We was getting those, but she was doing the square root too.
No, because we would need, because like if we do 1/3, right? And then times 3,
Uh-huh,
then you do the square root, that'd be the square root of 1.
right.
And the square root of 1 is how we get this one.
So what did I do wrong?
You were taking the square root of that 1/3.
So I don't, yes, so revert.
Yeah, sorry.
Revert the last
So-
step of, I'm so sorry.
It
I'm
happens.
mixing up steps here. We gotta back it up a little bit.
Yeah. Really quickly, what I will point out to y'all is this. The square root, that's the main operation, right? That is not a part of the transformation. You only look at the transformation and figure out what the transformation is to get those new x values. So, the fact that it's a 3, we need the multiplicative inverse of 1/3.
Right, so you're still multiplying by the multiplicative inverse, you just will not take the square root of it. Like after. Right? like,
So what is the same
so
step?
like everything we just did except the very, very last step, like, don't take, because, okay, so like, let's redo these values. So we'll do, to find our new x values, we're still multiplying by the multiplicative inverse of whatever this value is, which we determined was 1/3. So we're still multiplying that times these x values, okay? So 1/3 times 1 is
1/3.
1/3, okay? And then so I guess, should we just continue to write these as
Yeah, I would.
decimals?
I would just write it as a fraction.
Okay, so you can just write it as 1/3 here.
So you don't
And
square.
then you get
No square root.
root on the table.
No, okay, just slow down a second. Okay, so then for the next one, let's see, Kyle. How am I gonna figure out, or what input values am I gonna multiply to find the transformed x value here?
Yeah, I'm so lost.
Okay, so what did we do to find this x value? What did we multiply? 1 times, okay, why did I multiply times 1/3? Because it's the,
What's bigger than ever?
okay, because we were multiplying this x value times the multiplicative inverse. So what do I need to multiply next?
Oh,
Times,
1/3.
okay, because 1/3 is that,
What's bigger than
okay, because I'm multiplying by the multiplicative inverse, and that's gonna give me 4/3. We can just keep those as fractions.
The last one gets the whole.
Okay, so Omar, help me out here on this last one. What do I need to multiply?
1/3 divided times
Okay, so 1/3 times 9, and then if you put that in your calculator, that would simplify down to 3. Okay, and no square root, or no if it was a square or anything like that. I am sorry. Okay,
It's logical. It makes sense. You just have to. The big thing is to remember, the main operation is the defining operation. That's not a part of our transformation.
okay. So now looking at this, okay, so this was how we find our values going this way. So now this question asks us, what if instead of a 3 times the square root of x, we actually had a negative 1/3 as our multiplicative factor. So in your groups, take about a minute to discuss, or maybe like 2 minutes to discuss how that would change this parent function. So it's asking if we multiplied by, or if this was the transformation instead of this, what would that look like?
And
Okay.
make an extra table, right? Did you already say that?
Yeah, so I put a table up here for me to show you guys, but it would be helpful if you just add that to the bottom of your paper. So on your paper, you already have these two, and then you can just add this one below it. So that might help to talk about the kinds of transformations that would occur, and then we can kind of talk about the table and the mathematical calculations of it up here together.
So, let me work. I was going to talk with you about this.
Yeah.
The reason why I'm using F here instead of one of these is for the purpose of, I want the actual factor. And so I wouldn't ever call this the factor, for the sense that I need actually the multiplicative inverse of that. So the factor would be the factor. That's just the coefficient.
No, yeah, I guess it's just when you're talking about.
You naturally want to call that the factor, but the factor is what we actually need. Does that make sense?
Yeah.
So I would always call the factor what I'm dilating by. So even though it's a 3 here, my factor is 1/3, which is that compression idea.
I got a question.
Yeah,
Does
I
that
see what
make
you're
sense?
saying.
Alright, so that's the move to me, like, what is the factor for that one?
okay.
I mean, every score.
No, we're not doing that, we're not turning it as a
Okay, so this question is asking you if you have
So
this
Sarah, let me ask you a question.
Okay.
Which variable, which
So-
value are you going to change this
the
new
parent function of the square
to
root.
the x values or the y values?
So we're really glad.
So the y values are changing in this table?
And
Does everyone agree with that statement?
agree.
Push back on it? Why do you not agree?
So what's that new factor? So like, you see these changes where.
What do you think about that? That makes sense.
So.
Notice, literally, where's that negative one third, right next to what
Okay,
here?
yeah, so
Yeah, remember when it's
all
the
the
main
things
operation is
we're gonna
horizontal?
go
So we
to
gotta
those
always focus
values.
on that idea first.
So I created
Which direction is it horizontal, especially because anytime it's horizontal,
up there
it's
together.
actually gonna add the power. Right? So we need that multiplicative inverse.
Yes.
Any questions about that before I get away?
Is it negative 3 or 3?
Hey man, I'm just doing what
Well,
we're just doing.
what does the negative do?
Yeah.
Not the negative, what does the negative do?
Taking the reciprocal. So what's the
You gotta remember,
reciprocal of
the
the
negative
negative?
is a different transformation than a dilation.
That's what
Multiply by
it is.
negative, what does it do?
It's just
Yeah.
3.
But you still wanna have that negative.
Here, let's look at it.
You still want that negative, because what is that negative gonna cause that function to do?
Ah, so remember the negative creates a
Oh,
reflection.
but I was.
What's it dilation? So you can do those on the same
Okay,
step.
so by adding that
Separate
negative in
them
there,
into a
we're
reflection
changing
and
the dilation and we're now reflecting it over.
Would that reflect and dilate?
Okay, so
Yeah, this all.
So the x values
So
are
we
gonna
have
change,
new
the same, which means the y
transformations, so
values,
it's gonna
or
change the
the x
numbers a
values are
little
gonna
bit.
change, so the y values will change. We already have that.
We're trying, so we're going from
Still
this.
0, 1, 2, 3.
I was just using.
So we're having from here to this one instead of here to here.
How we doing?
You're changing these. So you're gonna change, think about, are the x values gonna change?
So let me ask you this first question.
Yeah, x values is.
Which values are changing?
Yeah.
Which ones are staying the same?
Yeah. We're gonna go, and we're gonna go over how to calculate the values again.
Okay, but is it always just gonna stay, the y's are always gonna stay the same?
9, 8, 8.
So it's inside the main operation, right? Inside the main operation means it's horizontal or affecting the x, so the y
So
is
don't take
exactly the
the,
same.
don't take the square root.
So,
But what did you
how
multiply
we doing
these
that
x values by
test?
now?
I'm at 88.
Not negative 1/3, take the reciprocal.
What's the call? I wasn't even here for other phases of the book. I was getting them, but I wasn't getting them at the same time.
So remember.
Sorry, not these, multiply these x values by
People that got
negative 3 to get
today's test corrections.
Yeah.
The inverse. So remember,
Okay.
the distinction is
Which one?
you can have.
We're gonna think about it and we're
opposite
gonna do it.
of this, right?
Oh,
But
wait.
remember,
Yes.
that, the opposite is only that add to the.
Okay, so it's saying, if this is like our parent function, and then this is the transformation, how is this transformation gonna be different from how this was?
What is the?
So we had this transformation, what do we actually have to multiply by to get these numbers? Okay, so what are we gonna multiply with this transformation to get our new
Right,
values?
and that's where you have to be careful, the opposite is how you need to add.
Okay, so, but you're gonna be multiplying from the parent, which is that. So you're taking this table and this transformation
Well,
to
so
get your new x value.
both-ish, so
Okay,
here's
so
why I say
then
both-ish.
also keep in mind, what
What
is multiplied by
transformation
the
does that
negative for each?
Right, so notice that we can say it separately as a reflection and then a dilation
By multiplying by
degree.
negative.
Or we can just do that single
Yes,
operation.
okay, so now, also
Does that make
considering that, we have a two
So,
transformation.
you can do it separately and do both at the same time.
Does that help you out a little bit, Kenny?
Oh, so you must know.
Does that help with behind it? We're gonna go over how
Okay,
to
so why do you know the y says something?
but just understanding now, multiply by
mean,
reciprocal.
Do y'all agree with that statement? Why?
Yeah, just say they translate these functions.
Miss Courtney.
Yes, yes.
Make sure I'm right.
I want you to be careful though, you just said translate from the old table. What's the issue with that statement?
Yes, ma'am.
Anyone know the issue I have with that?
Yes. I feel better about it now.
If I'm able to, I'll start trying to correct you guys. Understand.
So, remember a translation is only created through one operations. Addition and subtraction. I don't have that here, so what could you say?
So it's
Transform,
the
right? So that's something I want you to be careful about, is that translations versus dilations or whatever. But just like, I can't call this a line, right? Because that's not a line, but it is a curve, so I can call it a curve. All of these transformations, you can call transformations, but only one of them is a transformation. So that's one thing I want to push on. So, go back to what you were just saying. before all that? I have no idea.
Oh, but check it out.
So, the question was, why do we know the y values are staying the same? Okay, right here, pause. Because we need to have this whole group discussion, right? You said the y values stay the same. Why do we know that? Okay, so we need to make sure we understand it. So yeah, notice what we're literally saying here, f of x, remember, is the square root of x, right? Okay, so this can be substituted in for x, so we're looking at the square root of negative 1/3 x. That's what we're looking at. So you're saying it's inside the main operation, so it has to be which direction? You see how it's literally affecting the x? It's a horizontal idea. So am I changing the vertical, the y's at all? So the vertical, the y stay the same. So 0, 1, 2, 3 is still our y values.
We'll get to you in a minute.
No.
You agree with that?
Yes.
Okay. Do you agree with that? Okay,
I'm
being
Hey, Mr. Kenny. So y'all
Okay,
talk about it, we'll come back and check.
Let's come back real quick and start talking about this. So, can I get, let's see. Wait, what? No, I know they're right on board. Okay, oh, let's see what we're. So, can I get a group to tell me what kind of transformations are gonna occur from, or like what new transformations we're gonna have from this?
It's gonna do the reciprocal of the negative
Reflection.
Yeah.
Okay, so how do you know we're gonna have a reflection from here? We'll talk about the reciprocal in a second.
You're multiplying by negative.
Okay, so now multiplying by the negative, okay, so what kind of reflection are we gonna have here?
Dilation, reflection.
No, okay, so dilation and reflection, remember those are two different transformations. So I'm asking you what kind of reflection, we need to look at where is this is it, we're gonna go a vertical reflection or a horizontal reflection? So we're gonna reflect horizontally because,
They're multiplying by negative by 8.
okay, so we're multiplying our negatives by the x. And then also, Allie, what's gonna happen when this coefficient's a 1/3, how is that gonna change my transformed x values? So, well, if I have a 1/3, what am I actually gonna need to multiply by? The reciprocal. So, Allie, what's the reciprocal of a negative 1/3? Thanks, Allie. Allie, so do you know what I mean when I'm talking about the reciprocal? Okay, so just remember when we're talking about horizontal transformations, we have to multiply by whatever the inverse is. Okay, so I'm going to multiply, well also let's talk about, we've said what values are going to change, what values are staying the same here. Okay, so we can go ahead and rewrite our y values. Okay, so now to achieve my new x values, yes.
I knew that the y value was gonna stay the same, but I don't know why.
Okay, because look at where our transformations are happening with our main operation. Okay, the negative is on the inside, and that dilation, multiplication is all happening on the inside of the square root. When we do our practice in a little bit, we'll see some examples of dilations that happen on the outside of the square root or on the outside of the absolute value symbol, so you'll see what those vertical ones look like too. But, so we're going to finish up these horizontal notes. Okay, so, okay, so now we need to multiply these x values by, we said a negative 3 over 1. So we can just multiply them by a negative 3. So what did you guys get for your new x values? 0.
Negative 12 and negative 27.
Okay, what are your questions about how we got these new x values?
I thought we were supposed to multiply by 1/3.
No.
Okay, so remember, you have to multiply by the multiplicative take the multiplicative inverse.
I'm saying.
So what's the multiplicative inverse of a negative 1/3?
Negative 3. I thought we were supposed to multiply -3 by 1/3?
We are multiplying from the parent function,
Oh.
which yes. So the question was asking to transform, like this transformation instead of this one. But from the same parent function. I guess that could have been a little bit more clear, but that's what we're talking about.
And I ain't even know that.
I'm sorry.
Always go back to the parent function.
Yeah, but it was,
You transform from the parent function.
okay, does anyone else have any questions about
So
this?
that's it, that's all we need.
And then maybe graph it sometimes.
Right, and so yeah, okay.
I mean, you don't have to do much though. You literally take those points and you put them on a graph. Must be really hard anymore. Let's go ahead and go to the practice for today.
Okay. Did you pass it down already?
Yeah, I did.
Okay, guys, so, we are gonna start, if you wanna go ahead and put those, or keep those notes out for your reference.
Yeah, I would keep those notes out. I see a bunch of y'all packing it up.
Also, good idea to have that graphic organizer out. You've got some really good key points on there. So for this first part, has 6 questions on it, and you're given the equation of a transformed function, and you're asked to do 2 things for each one. Okay? So for given each equation, you have to identify what the parent function is. So, you want us to do one together?
I think they can.
Okay, so just when you're, so I would write the name of the parent function and give me the equation. So I'll write that note up here, name and equation, and then identify the transformations that were applied. Okay, so that includes the direction. So remember, when we're talking about direction, what things do you need to clarify there? Okay, whether it's a horizontal transformation or a vertical transformation. Also, you're telling me what kind of transformation's happening. So what do we need to look at to know what kinds of transformations are happening?
The main operation.
Well, not the main operation, but within that main operation, what do we need to look at? Right, so we're looking at inside or outside. That tells us the direction. But what tells us if it's a translation or if it's a dilation?
If it's negative or positive.
If it's added.
Let's take 30 seconds and look at the graphic organizer that we wrote on today.
What's your question again?
It's quadratic. It's quadratic.
Okay, listen to how do you know, okay, so that, a lot of what you're telling me is talking about the parent function. What I'm talking about within, if we're looking at this very first one, what tells me if
Where?
that's the parent function?
Anthony, she hasn't even finished asking the question. This ain't Jeopardy. Just wait.
I'm asking what tells me, how do I know what transformations are happening? How can I look at this and know if there's a dilation being applied, or if there's a translation?
Operation.
By looking at the operation, so looking at the addition, subtraction, multiplication.
What?
I
Why did you say
did,
that?
but
You said the main
But,
operation.
so, okay, so just remember, use the graphic organizer to know what operations signifies certain transformations. And, so yeah, work in your groups, go ahead and do all 6 of them. Like,
We'll come back together after you do 1 or 2 to like establish them. But we want you to
Yeah, but
think
like-
about it first.
but go ahead and start working
I
through
know that
them
thinking
all.
thing.
And then we'll come back together and talk about them before you finish all of them, but,
Let's get to work.
yeah, let's go.
Inside.
What do you say?
Okay, so why do you do the whole box? Yeah, but you
Oh,
still have to
that's
have
everything.
it
What do you
right.
think about
right
Lamar's
here.
question? Just remember, like when we're talking, we should be talking as a whole class. So, can you ask your question, or what's your question?
Yes. So what's the, yeah, that's for transformation.
So this would be,
Okay, so yes, you would write the name and the equation.
So, inside, so we're thinking inside the main operation transforms it horizontally. Yeah.
So you're gonna, so is it horizontal?
Cause you about to lose that equation on
That's
your.
completely.
Right, so,
I was
Which
wondering,
one?
well, I mean, I appreciate not.
okay, so that one,
Three.
but also there's two,
That's
so
what
that's,
it
you have
Is
a
that
verb,
four?
so you wanna list
And
R.
then that one half is what you're
So
referring
I
to?
said the three would be doing.
Do we all agree with that idea?
Yeah.
Okay, now I need you to be careful, because when
So
you
you would say,
move,
a
what
vertical,
transformation are you implying?
what kind of transformation is that? That two is doing
Yeah, when you
what?
say move, it's a
So
translation.
the right value,
Is that
Right,
plus
so
three,
what-
that
what
four,
transformation?
and that
Which one
one
of
half,
these?
all translations
the
though?
who, which one is it?
Yeah, which one of these is it?
No.
Okay,
So
so
that's
you would
what we're
say-
thinking.